all know that smooth gameplay is the holy grail for PC gamers, with higher frame rates promising a more responsive and immersive experience overall. AMD's Fluid Motion Frames 2, or AFMF2, claims to take things to the next level, potentially changing the game for PC gamers. But is this new technology really a must-have feature for your next GPU purchase? Or is it just another buzzword that marketing would like to use to show better results? AFMF2 isn't just another frame generation technology, however. It's an AI-powered technology designed to enhance frame rates and smoothness across literally thousands of games. Now, this could be a big deal for those with AMD graphics cards, offering a way to breathe new life into both older and newer titles alike. In this video, we're going to deep dive into AFMF2, or AMD Fluid Motion Frames 2, exploring what it is, how it works, and most importantly, whether it's worth considering if you already own a compatible AMD card or are thinking about your next GPU upgrade. We'll look at its requirements, its impact on visual quality and performance, and even attempt to peek into its future potential for how it could be improved. So whether you're a hardcore gamer or just someone who appreciates smooth gameplay, stick around as we unpack everything you need to know about AFMF2. But before we get into that, here's a quick word from this video sponsor. My PC's almost ready, I just need to get a cooler, but I'm kind of a bit low on cash now. What am I going to do? The Liquid Freezer 3 from Arctic. It's available in up to 420ml, and you can have it with or without RGB, and it comes with a 6-year warranty. And it's cheaper than all other AIOs on the market. Yeah, it's pretty cool, isn't it? Hold on a minute. The Arctic Liquid Freezer 3. Find out more by clicking the link in the description below. Now, before we get into the nitty-gritty of AFMF2, let's take a quick look at what frame generation technology actually is. Frame generation is a technique used to increase the perceived frame rate of a game by creating intermediate frames between natively rendered frames for the GPU. The goal is to provide smoother motion and a more fluid gaming experience, especially when the native frame rate might be lower than desired. DLSS and AFMF2 broadly do the same thing with this, but with differing implementations. Traditional frame generation techniques have been around for quite a while, often used in TVs and some gaming displays. However, these methods often introduced artifacts, or a sense of smoothness that didn't feel natural for gaming. AMD's first attempt at game-specific frame generation came with the original Fluid Motion Frames, or AFMF1, which was integrated into their Adrenaline software as part of the HyperRX suite of performance-enhancing features. But here's where AFMF2 kind of differs. Unlike its predecessor, AFMF2 isn't just a simple frame interpolation technique. Instead, it's an AI-enhanced frame generation technology designed to create more accurate intermediate frames in real time. This is particularly useful for enhancing the smoothness of games across a wide range of hardware, from high-end GPUs to integrated graphics in AMD's very own Ryzen processors. This approach sets AFMF2 apart from both traditional frame interpolation methods and other frame generation techniques. While standard methods might simply blend frames together, AFMF2 uses advanced algorithms to make more intelligent decisions about how to create intermediate frames, taking into account motion, occlusion, and other factors that affect visual quality. The result is a technology that promises to boost frame rates and smoothness across a vast library of games, potentially making your entire gaming experience more fluid and more responsive. It's a unique approach that aims to bridge the pitfalls that occurred with AMD's first attempt at frame generation with AFMF1, which was released back in 2023. So it's been a little while, and it's nice to see that they're continuing to develop on it. So the big question is, how does AFMF2 work? Well, at its core, it uses AI-optimized algorithms to generate intermediate frames. The process starts by analyzing the frames rendered by the GPU. Then the AI model predicts and generates new frames to be inserted between the original ones. This results in a higher perceived frame rate and, of course, the main thing, smoother motion. Now, one of the key improvements in AFMF2 is the introduction of search mode, which controls frame generation smoothness by improving how fallback works. Fallback refers to when frame generation is temporarily disabled in high motion scenes to ensure the best interpolated image quality. AFMF2's optimized algorithm reduces the need for fallback, resulting in improved smoothness. In AFMF2, the search mode auto setting automatically selects high mode for resolutions of 1440p and greater, which reduces fallback for improved smoothness. For 1080p, it uses the standard setting, which is optimal for this resolution, and these improvements aim to provide a better gaming experience across different resolutions compared to AFMF1. Now, you might be wondering what you need to actually use AFMF2. First and foremost, you'll need an AMD graphics solution based on the RDNA2 architecture or newer. This means AFMF2 will work on Radeon RX 6000 and 7000 series graphics cards, as well as select AMD Ryzen processors with integrated graphics. On the software side, you'll need to be running the latest preview driver of Adrenalin, which integrates AFMF2 as part of the AMD HyperRX suite. It's worth noting that AFMF2 is currently released as a technical preview, so issues with this driver may occur as it's not officially released yet. It's also important to mention that AFMF2 is supported on RDNA 2 and 3, but HyperRX is only supported by RDNA 3, so we'll be testing the RX 7000 series for this today. As for game support, AFMF2 works across a lot of games, and one of the big improvements with this update is the added support for Vulkan and OpenGL games. This further increases the already vast number of titles that can benefit from AFMF2. As it's operated from the driver side, it has near universal game support, depending on the framework the game is built from, but your results may vary due to this. It's also worth noting that AFMF2 now supports borderless full screen mode when using AMD Radeon RX 7000 and Radeon 700M series graphics cards, in addition to the previously supported exclusive full screen mode. This added flexibility can be particularly useful for users who prefer to quickly switch between their game and desktop, maybe streamers or someone who's recording stuff. When it comes to the visual impact and performance improvements of AFMF2, the results are more nuanced than you might expect. In our testing across a range of AMD GPUs, from the high-end RX 7900 XTX to the more budget-friendly 7600 XT, we saw varying degrees of improvement across different games and resolutions. We looked at native performance, then compared it to results with HyperRX enabled, AFMF2 on its own, and finally AFMF2 combined with AMD's anti-lag technology. Now, one thing to keep in mind, AFMF2 isn't compatible with popular frame rate monitoring tools like RTSS, so you'll need to rely on AMD's built-in metrics for accurate readings, at least at this point. So, it all sounds all well and good on paper, but how does that translate to actual in-game performance? Well, to find out, it's time we have a look at those glorious benchmarks. Benchmark. So since there's so many charts to go through and we see a lot of patterns, we'll go over the first chart in a lot more detail than the others to show what patterns we noticed before we move on to take a general look at the rest of the charts. Starting things off at the bottom of the stack with the RX 7600, where at 1080p we can see some impressive improvements right off the bat. Baldur's Gate 3 started off strong at native with 90 FPS, but enabling HyperRX saw us jump up an impressive 58% in the averages and an even more impressive 157% in the lows, bringing them up from below 60 to over 120 frames per second, which is something most gamers want from the averages, let alone in the lows. Interestingly though, as we look at the performance when we simply enable FMF on its own, we see that the performance is up once again, this time by 80% from native, which is also 14% more performance than the HyperRX preset. Enabling anti-lag on top of FMF doesn't really change much, as the FPS only drops by a single frame, which comes down to margin of error difference, so as far as I'm concerned, shows that they performed identically. Cyberpunk saw much of the same thing, with HyperRX performing 58% higher than native, whilst fluid motion frames on its own jumped up even more, giving us 90% more frames than native, almost doubling the performance. Anti-lag again sees performance drop a little, but with a decrease of only 2%, it's still only margin of error, and will obviously reduce latency at the same time. Elden Ring was probably the most interesting game to test for us, as it's the only one with an FPS cap, or at the very least, the only game with an FPS cap that we could reach. With a cap of 60 FPS, we were curious what fluid motion frames would actually do, and if we were going to see any kind of improvements at all. And to our surprise, we actually did see improvements, with fluid motion frames doubling the frame rate. What is a little interesting here though is that enabling anti-lag saw a better 1% low FPS, going from 99 FPS on FMF alone to 105 FPS when enabling anti-lag. And with that working out to 6% more FPS, this actually falls outside of margin of error, and even though HyperRX did once again come a little under FMF on its own, it did still reach an impressive 91% more performance compared to native. Now, some of you may have noticed this already, but for those who didn't, both FMF alone and with anti-lag both achieved 120 FPS, which is exactly double the native frame rate. And this is no coincidence. We were actually seeing the same FPS cap as before still taking effect, though what we essentially did was just double the cap. So keep an eye on the rest of the Elden Ring tests and you'll notice a bit of a trend. Moving on to Horizon Forbidden West, and here we see the smallest increase so far, with both FMF and FMF with anti-lag seeing a 32% improvement over the native preset. Now it is worth noting though that the improvements in the lows are slightly smaller when anti-lag is enabled, seeing 28% more performance over native as compared to the 34% when anti-lag isn't enabled. But at just 3 FPS this isn't really much of a worry. Interestingly though, HyperRX sees the best boost in performance with 37% more frames over the native result and is a bit of a turn up for the books. The last game for this card is Starfield, and this one is interesting because, as you can see, all the results are, well, pretty much the same, with the exception of a single FPS bump with HyperRX enabled. But as it's just a single frame, this counts as margin of error and is more or less identical. So what happened here? Well, to be honest, I'm not sure, but for some reason we saw no improvements from FMF. But this isn't the end of the world because Starfield has FSR3 built into it. So if you're looking to use frame generation in this title, you can just enable it in-game and potentially get a better experience anyway. Now before we continue, it's worth mentioning that I'll mostly be ignoring Elden Ring and Starfield from here on out, as the trends we saw there stuck around throughout all of our tests. But rest assured that if something interesting does happen, that I will be mentioning it. Right, so with that out of the way, we can now speed things along and move on to 1440p, where we see a lot of the same trends that we saw before. Baldur's Gate 3 sees HyperRX performing 58% better than native, with FMF alone performing 78% better, whilst anti-lag introduces a single FPS drop from there. Cyberpunk 2077 sees some difference though. HyperRX has a 63% improvement over native and is the smallest of the improvements, with FMF alone performing higher than that with 72% more frames than what we saw at native, but this time around enabling anti-lag saw the most performance increase over native by quite some margin, with 89% more performance than having no FMF at all. Horizon again is seeing the smallest actual difference from enabling AFMF2, but that's not to say it's useless as we do see some increases, with HyperRX seeing the smallest increase at 48% more performance than what we saw at native, and then from here it only gets incrementally better, with FMF alone getting 54% more FPS and FMF with anti-lag getting 61% more. And whilst these jumps in percentage sound quite impressive, it's worth remembering that each jump only equates to 2 FPS, so it's really nothing major and arguably margin of error. Moving over to the 7600 XT, we find that at 1080p again we find more of the same, with Baldur's Gate once again seeing some pretty large jumps in frame rates from enabling FMF, with that alone being the biggest of the jumps with 90% more performance than native. Cyberpunk is very similar, with HyperRX seeing 58% more performance on average, whilst FMF on its own and with anti-lag enabled both get borderline identical performance improvements, only separated by a single FPS, which comes out to around 84% more frames than native could actually provide. Horizon Forbidden West again sees some improvements, but interestingly the frame rate seemed to cap itself at 99 FPS, as none of the FMF settings that we tried managed to reach over that, meaning all of them performed 54% higher than the 64 FPS that we saw at native. At 1440p in Baldur's Gate 3 we see HyperRX bringing the smallest in the improvements with 57% more performance than native, whilst FMF and anti-lag ended up being the best performing with 78% more performance on average. Cyberpunk is proving to be a little unpredictable, as the best performing setting never seems to be the same, and in this case the best performing is fluid motion frames on its own, with an improvement of 85% over native. Horizon Forbidden West is up next, and here we see HyperRX and fluid motion frames both getting the same average FPS, landing them 63% ahead of native, whilst anti-lag ended up getting an extra frame on top of this, seeing 67% more performance on average. But something worth noting is that this was the result that had the lowest 1% low frame rate of the three. Next up is the 7700 XT, and at 1080p we see Baldur's Gate actually managing to reach a staggering 249 FPS on both FMF and FMF with anti-lag. This means that performance has jumped up by 81% on average compared to native, with HyperRX falling behind with 65% more FPS on average, which is still perfectly respectable but does fall behind the other results. Cyberpunk is next, and here we see pretty much the same thing as we did in Baldur's Gate, where both FMF and FMF with anti-lag both peaked at the same frame rate, this time of 213, meaning that they're both 88% higher performing than the 113 FPS that we saw at native. Horizon Forbidden West has some fairly impressive results here, with HyperRX actually being the best performing of all of the tests, with 64% more performance than running natively, and the other results falling just behind. though FMF without anti-lag did see slightly better 1% lows. 1440p has some more interesting results here, and starting with Baldur's Gate, we see FMF and FMF plus anti-lag providing the greatest improvements over native with 80% more frames than before. Cyberpunk has some interesting results too, with anti-lag providing significantly more performance over the other results, providing not only 104% more frames than native, but also 11% more performance over the next best performing result, which happens to be FMF without anti-lag. Elden Ring has something worth noting here. Despite all of the FMF results coming in with identical averages, there's quite a difference in the lows, where FMF with anti-lag ends up coming in a lot lower than the other results, performing 15% worse than the best performing result, that being HyperRX. So it shows that these technologies can differ game to game, card to card, and even resolution to resolution. Horizon is next, and here we find the performance being, well, pretty similar, with the best improvement we see coming by way of a 72% uplift in the average frame rate, and that being from both FMF on its own and with anti-lag, with HyperRX falling a margin of error behind them in this test. On to the next card, which is the RX 7800 XT, where we find at 1080p, Baldur's Gate sees even more uplifts, with FMF being the best of the bunch with 84% more FPS over native, whilst HyperRX saw quite a bit worse than that with 66% more performance, so still nothing to complain about, but not as high. Cyberpunk was pretty consistent here with only a few frames difference between each of the tests, and HyperRX took the lead with 42% more performance than average. Then Horizon saw pretty much the same thing as we saw in Cyberpunk, with all the results being within a margin of error of each other. But this time around, the best performing of the lot was FMF on its own, with 63% more performance compared to native. Then at 1440p, things don't change a whole lot. Baldur's Gate 3 has FMF with anti-lag performing the best of the results with a 78% improvement over native, though FMF with no anti-lag is only just behind. Then Cyberpunk sees FMF performing best on its own as it manages to reach 93% more performance than without anything enabled, nearly doubling the frame rate that we saw natively. Elden Ring has the same results as ever, but interestingly this time we see a 6% drop in performance, going from the 1% low figures of HyperRX and FMF alone to FMF with anti-lag, so improved latency but a drop in performance. Horizon Forbidden West saw only a single FPS difference between each of the FMF tests, meaning that all three of them ended up coming in with around the same 72% more performance compared to native, so still impressive nonetheless. Moving on to the 7900 GRE or GRE, and we find that Baldur's Gate at 1440p still provides plenty of uplift, with FMF managing to provide the highest increase of 77%, which is 13% greater than what HyperRX managed to achieve. So for some reason, HyperRX has something going on that is limiting the performance in this title. Cyberpunk is next, and here we see FMF and FMF with anti-lag performing identically in the averages, both sitting 85% higher than native. But anti-lag does see the lows drop quite a bit, now matching up with the HyperRX result, which performed 89% better than the native lows, as compared to the 101% that FMF got alone. Horizon next, and here we see HyperRX and FMF performing identically with 64% more performance than native, which is a pretty healthy boost, but we do see that the lows are higher with FMF with no anti-lag, even if only by a few frames. So, time for our first 4K test of the day, and starting off strong with Baldur's Gate, where we see FMF with anti-lag performing by far the best, around 5 frames higher than HyperRX and FMF on its own, and 74% higher than native, so there's really nothing to complain about here. Cyberpunk sees some pretty consistent results here too, with the 1% lows on all tests ending up identically, and only 1 FPS separating each of the average frame rates. The best performing though ended up being the HyperRX profile, which managed to achieve 85% more performance than native, bringing the average frame rate up from 41 FPS to above the 60 FPS threshold that most gamers want. Horizon ended up being much like Cyberpunk, with HyperRX seeing the best performance increase over running natively with 88% more FPS overall, so again, pretty impressive. Next up is the 7900 XT, and at 1440p we're seeing some pretty big differences in performance in Baldur's Gate, where HyperRX ended up being the lowest performing setting out of the three, with 60% more performance than native, which then jumps up when we look at the highest performing setting, which is FMF with anti-lag enabled. With this, we ended up seeing an extra 21% performance added on, bringing us up to a total of 81% more performance than the native result. Cyberpunk is still performing pretty much as we expect, with FMF being the best performing result, this time around with 88% more performance than native. Anti-lag sees performance drop slightly, and HyperRX then sees it drop even more. Horizon is up next, and again, much like we saw in Cyberpunk, the best result ended up being FMF on its own, with an improvement of 65% over the native performance, with the other results trailing just behind. Something interesting with this set of results is that we now see Starfield doing something different, and enabling FMF actually made a change to the frame rate. Not by much, but it's still something. And like Cyberpunk and Horizon, FMF ended up being the best performing result here, with 18% more performance than we saw at native. Whilst this isn't a whole lot compared to the other games that we've tested, it's still free performance, so I'm not going to complain. 4K now, and here we see Baldur's Gate seeming to behave a bit better. This time all three of the results were within margin of error of each other, and the best performing of them was actually HyperRX with a boosted performance of 72% over running natively. Cyberpunk saw the same result. HyperRX was once again the victor, this time with 95% more performance, almost doubling what we saw at native, and that brings us up to above 60 FPS where we weren't before. Horizon is again much like Cyberpunk, and we see HyperRX performing better than FMF and FMF with anti-lag enabled. And this time we're seeing increases in performance of 93% over the native result. Finally, our last card, the RX 7900 XTX, and at 1440p, Baldur's Gate remains the top performer, with FMF seeing the highest increase in frames over native with a boost of 54%. Cyberpunk was the exact opposite of that, with FMF being the worst performer of the three tests by quite some margin, performing 9% lower than the top performer, which was HyperRX, which saw itself landing 98% more performance than the native test, meaning that this is essentially double the performance for free. Horizon Forbidden West was a little different this time, now with FMF outperforming anti-lag and HyperRX, even if only by 3 frames per second, and giving us 70% more performance than native. Once again, Starfield actually did something here, and even though we saw basically no change on most of the results, we did see a jump up for FMF with 12% more performance than native. Lastly is 4K, and here we see Baldur's Gate managing to see almost identical performance over all three of the tests. But anti-lag does have a single FPS edge over the others, which means that it performs a nice 69% better than native. Cyberpunk is a bit different here, as FMF jumps up by 83% compared to native, whilst anti-lag ended up being the lowest performer by 10 FPS, which is more than margin of error. In previous tests we saw much closer performance, but on this combination of card, game and resolution, well, it took a bit of a hit. In Horizon Forbidden West, and this is, well, an easy one, both HyperRX and anti-lag ended up performing identically in the averages, whilst FMF saw a single FPS jump over that, meaning that we saw 78% more performance than native at fluid motion frames best. Then, lastly in Starfield, we did see a slight difference of a few FPS over native, but nothing really worth talking about. So some interesting results and an uplift in performance is always welcomed. Now, one of the most significant drawbacks that some gamers may notice is that AFMF2 can introduce visual artifacts in some scenarios. While these artifacts are generally less noticeable than in the first generation, they can still be apparent in fast-moving scenes or games with lots of fine detail. This could be particularly problematic for players who are sensitive to visual inconsistencies. While AFMF2 aims to improve smoothness, it doesn't always translate to a better gaming experience. In some cases, especially in competitive games where responsiveness is crucial, the added latency, even if reduced compared to AFMF1, might outweigh the benefits of increased frame rates. Now, speaking of latency, AMD claims, and we all know what that can mean, but AMD claims to have made improvements in this area with AFMF2 in their testing with Cyberpunk 2077. AFMF2 combined with AMD's in-driver Radeon anti-lag technology delivered on average 28% lower latency at 4K using the Ray Tracing Ultra Graphics preset when compared to AFMF1. For competitive gamers, the combination of AFMF2 with AMD's new in-game Radeon Anti-Lag 2 technology showed some promise, with tests for Counter-Strike 2 on a AMD Ryzen 7 8700G processor with Radeon 780M graphics. AMD reported that AFMF2 plus Anti-Lag 2 improved latency by an average of 12% over AFMF1 alone, while still delivering over 120 FPS at 1080p using the very high graphics preset. While these latency improvements are promising, it's important to remember that they may not be uniform across all games or hardware configurations. The actual impact on your gaming experience will depend on various factors, including your specific setup and the games you play, as the base frame rate will determine how much of a difference there is on your end specifically. Now, I did mention about the future, so looking to the future, we can expect to see continued refinement and improvement of AFMF2 as AMD continues to develop it and fix issues with the technology before it's released to the stable driver, as AFMF2 is currently released as a technical preview. So user feedback will play a crucial role in, I guess, shaping its future. We might see improvements in how the AI handles different types of game scenes, potentially leading to more consistent performance across various games. And, the main thing, reducing visual artifacts, which, I mean, them two things combined, I'm all for. So, is AFMF2 worth it? Well, that depends on your gaming preferences, setup, and, of course, the big one, your expectations. For gamers with high-end AMD graphics cards, especially those playing graphically demanding single-player games at high resolutions, AFMF2 could provide noticeable improvements in smoothness and perceived frame rates. However, for those with, I guess let's call it mid-range or budget GPUs, or for competitive gamers prioritising low latency, the benefits might be less pronounced or even counterproductive. The pros of AFMF2 include potential frame rate improvements in some games, reduced latency compared to its predecessor, and wide game compatibility, including new support for Vulkan and OpenGL titles. The customizable search mode allows users to fine-tune the balance between smoothness and image quality, which can be useful for different types of games. So at least you have some form of dialing settings specifically to you and the games that you play and what you're actually expecting to see when you enable the technology. However, with the pros also comes the cons, and the cons are pretty significant and shouldn't be overlooked. AFMF2 is only currently available for AMD RX 6000 lineups or newer, so there is that. If you're on an older card, sorry, but you're going to have to upgrade. Its effectiveness varies greatly between games and even within different scenes of the same game. Visual artifacts, while reduced compared to AFMF1, are still present and may be noticeable to some players, so be mindful of that. There's also one glaring issue which is still present with AFMF2, and it's the fact that it will switch itself off briefly in games still if the scene is, demanding enough. The addition of the fallback mode is intended to limit this, but it doesn't fix the problem which existed with the original implementation. But again, this should get better over time. Ultimately, whether AFMF2 is worth it for you will depend on your specific gaming habits, the types of games you play, and your tolerance for potential visual artifacts and increased latency. Given that it's included as part of AMD's driver package, well, there's little downside to giving it a try if you have the compatible hardware. However, don't expect it to be a magic solution for all your performance needs across all games, as we showed today. So yeah, that's going to, wrap it up for this one. Hopefully you enjoyed this deep dive into AMD's Fluid Motion Frame 2 technology. If you did, a like and a sub to the channel would be amazing. And if you love what we do, consider supporting us over on Patreon, where you'll get access to a whole host of goodies, including behind-the-scenes content, access to our testing data, bi-weekly game nights, meetups at the eTeknix offices, and much, much more. The link is, as always, down below. Thanks for tuning in, and don't forget to give AFMF2 a try if you have a compatible AMD GPU or, in some cases, compatible CPU. Your feedback could actually help shape the future of this technology, so I guess it's in your best interest to do just that. For now, I'll see you in the next one. See you later, guys. Bye-bye.